Hello once again. As the next problem, I have chosen a mixed number theory algebra Olympiad question. Let's read the question. Third root from n plus 7 over n minus 7 is an integer. What is n? Let's rewrite the question. We have third root n plus 7 over n minus 7 is an integer. What is n? Let's make a short analysis about this question. First of all, third root from something to be an integer, we must have the expression under the root to be a cube. But in the first plan, it must be an integer also. So let's make these two notes. N plus 7 over n minus 7 must be an integer. And the second thing is n plus 7 over n minus 7 must be a cube. A cube of an integer. Let's try to use these notes and to make appropriate move, so to solve the question. Let's look at the first note. N plus 7 over n minus 7 must be an integer. Let's try to go in this way. We have n plus 7 over n minus 7 is equal n minus 7 plus 14 over n minus 7. This is the same. So let's make two fractions here, n minus 7 over n minus 7 and plus 14 over n minus 7. And this is equivalent to 1 plus, I'll write in the other row, this is equivalent to 1 plus 14 over n minus 7. And this must be an integer. Obviously, 1 plus something to be an integer, that something must be an integer also. So, we can conclude that 14 over n minus 7 must be an integer. Let's figure out when this can happen. Obviously, n minus 7 must be a factor of 14. N minus 7 is a factor or a divisor of 14. But we are working in the set of integers. The only divisors of 14 are plus minus 1, plus minus 2, plus minus 7, and plus minus 14. So we have few possibilities for n minus 7. N minus 7 could be equal to plus minus 1, plus minus 2, plus minus 7, and plus minus 14. This means that n could be, let's calculate, in the first case 8, after that 6, 9, 7 minus 2, 5, 7 plus 7, 14, 7 minus 7, 0, 7 plus 14, 21, and as a last possibility, 7 minus 14, minus 7. Let's order them in increasing order. Minus 7, 0, 5, 6, 8, 9, 14, and 21. So only for these values of n, n minus 7 over n plus 7 will be an integer. But that doesn't guarantee that we will have a perfect cube here. Because of that, we must check what's happened with the fraction n plus 7 over n minus 7. Let's make a table. Let denote a n plus 7 over n minus 7. And let's make one table for these n's. Let's make like this. And a. We have minus 7, 0, 5, 6, 8, 9, 14, and 21. In these cases, we will have respectively a equal to what? For n minus 7, this will be 0. For n0, this will be minus 1. For n5, it will be 12 over minus 2. It is minus 6. 6 plus 7, 13, minus 13. 15 stays 15. 9 plus 7, 16 over 2. It is 8. 21 over 7, 3. And in the last case, 28 over 14, 2. But because of the second remark that A must be a perfect cube, so A to be a perfect cube, n must be equal to, let's see, what are the possibilities when A is a cube? That is 0, minus 1 is a perfect cube, and also 8. So n could be equal to minus 7, 0, and 9. So we have three values for n for which the given expression is an integer. Thank you very much. See you soon. God bless you.